The vector addition simulation is an interactive educational tool designed to help students explore and understand the principles of vector addition in both one dimensional and two dimensional spaces. By providing a hands on approach to investigating how vectors add together, the simulation offers a comprehensive learning experience that covers fundamental concepts in mathematics and physics. The simulation allows students to experiment with vector addition, specify vectors in Cartesian or polar coordinates, and observe the magnitude, angle, and components of each vector. Additionally, students can play with two sets of vectors and compare their sums, as well as add up to 10 vectors of the same type. The vector addition simulation begins by exploring vectors in one dimension, which helps students understand the basic principles of vector addition. In one dimension, vectors can be represented as points on a number line, and their addition is straightforward. By adding vectors in one dimension, students can gain a foundational understanding of how vectors combine to form a resultant vector. The simulation provides visual representations of vectors in one dimension, allowing students to see how vectors add together. For example, if a vector A has a magnitude of 3 units to the right and a vector B has a magnitude of 2 units to the right, their sum will be a vector with a magnitude of 5 units to the right. This visual representation helps students grasp the concept of vector addition more easily. The simulation also allows students to experiment with vector addition in two dimensions. Students can specify vectors in either Cartesian xy coordinates or polar magnitude angle coordinates. This flexibility helps students understand the different ways vectors can be represented and how these representations relate to each other. Students can observe the magnitude, angle, and components of each vector. The magnitude of a vector is its length, the angle is its direction, and the components are its projections onto the x and y axes. By manipulating the vectors and observing these properties, students can gain a deeper understanding of the characteristics of vectors. The simulation allows students to play with two sets of vectors and compare their sums. This feature helps students understand how the addition of vectors can result in different resultant vectors depending on the magnitudes and directions of the individual vectors. By comparing the sums of two sets of vectors, students can develop their intuition about vector addition and its applications. Students can also add up to 10 vectors of the same type. This feature allows students to explore the cumulative effect of adding multiple vectors. By adding more vectors, students can observe how the resultant vector changes and understand the principles of vector addition in more complex scenarios. The simulation provides an interactive platform where students can actively engage with the concept of vector addition. By manipulating vectors and observing the results, students can gain a deeper understanding of the principles governing vector addition. The visual nature of the simulation makes abstract concepts more tangible. Students can observe the addition of vectors in real time, helping them to grasp complex ideas more easily. The simulation allows students to specify vectors in both Cartesian and polar coordinates. This flexibility helps students understand the different ways vectors can be represented and how these representations relate to each other. Immediate feedback. The simulation offers immediate feedback, allowing students to see the results of their adjustments instantly. This helps correct misunderstandings quickly and reinforces learning through trial and error. The simulation covers a wide range of topics related to vector addition, including one-dimension and two-dimension vector addition, magnitude, angle, components, and the comparison of vector sums. This comprehensive approach helps students gain a holistic understanding of vector addition and its applications in various fields. The vector addition simulation is a valuable tool for teaching and learning about the principles of vector addition in both one-dimension and two-dimension spaces. By providing an interactive, visual, and comprehensive platform, it helps students understand the fundamental concepts of vector addition, including the representation of vectors in different coordinate systems, the observation of magnitude, angle, and components, and the comparison of vector sums. Whether used in a classroom setting or for individual study, this simulation can significantly enhance the learning experience and build a strong foundation in mathematics and physics. Through exploration and experimentation, students can gain a deeper appreciation for the complex and fascinating world of vectors and their applications in various scientific and engineering fields.